Hi everyone, this is a flip video about significant figures, but specifically adding and subtracting. Before we begin in talking about how to do significant figures when you add and subtract, I want to remind you about our definition and what sig figs actually means. So take a second and write this down. Significant figures, I can't even talk today, significant figures are all the numbers in your measurement that you're certain about, plus one guess. So if you have a measurement, for example, let's say we say that my measurement is 2 centimeters, 2.0 centimeters long, then all of these digits are significant, right? Significant non-zero number. Trailing zero with a decimal is significant. Then therefore I am certain about this part, certain. Remember to write all examples down. And I am uncertain about the tenths place. We call that our guess or our estimate. Both of these we call significant figures, right? That is significant, that is significant. So all the places we're certain about in our measurement are significant, as well as we get one extra guess. Together, these make up what we call significant figures, okay? Another quick reminder is, if I'm actually going to take my pencil and do a measurement here of my pencil, I look at my scale, right? This might be a ruler in centimeters, and I notice, wow, this is one stinky ruler because the only increments I see go up by ones. There are no other increments, no other tick marks to help me here. That's kind of a bad ruler, but this is what we have to work with. So I'm for sure certain about my ones place. I see them all on the scale. 1, 2, 3. Okay? Let's try to see if we can line up where the tip of this pencil goes on our scale to take a measurement. So I know my measurement is for sure 2 something. It's between 2 and 3. Not exactly halfway, a little bit more than half. So I am certain about the 2. Certain. But I'm uncertain about this next place. But remember, I get to have a guess, we call uncertain, right? Or again, a guess or an estimation. And so I'm going to estimate, I'm going to guess that to be about 2.7. That's what I'm estimating. Don't forget, every number has a unit on it if it's a measurement. So now, what does that mean? That means that my significant figures are all the places I'm certain about and the one extra guess. So together, these are all significant figures. Okay, so that's just a quick review. Now, what if I wanted to take my measurements and add them together? So for example, earlier I had a 2.0 centimeter measurement, and let's say the lab or the activity says, take your 2 measurements and add them together. Well, this was done with one piece of equipment, and who knows what piece of equipment we use for this. So when we're going to take measurements and add or subtract them from each other, we have to apply a sig fig rule. And this is the rule. So take a second and write down the rule. When adding and subtracting, your answer is determined by the least amount of places after the decimal. And when you need to, you're going to round. Okay? So go ahead and write that down. All right, what does that mean? All right, so here we go. Let's say these are my measurements. I'm going to take my 2 centimeters that I measured somewhere on some piece of equipment, and I'm going to add it to 1.0 centimeters. So before we even begin, if I look at these 2 numbers, I can make a quick judgment about the piece of equipment I used. This equipment, this ruler that I used to measure the 1.0, clearly is a better piece of equipment because it allowed me to go to the tenths place. Whereas this piece of equipment, this ruler, must have been a different ruler because it only allowed me to go to the ones place. Only the ones place. So clearly I know that this one is going to be the limiting one. It holds me back from making more of a measurement. Our answer is only as good as our weakest measurement. This is my weakest measurement. Okay? So if we look here, I write that there's no places after the decimal. I don't even have a tenths place on this number. So that's the one with the least places after the decimal. This one has one place after the decimal, but again, this one doesn't. My answer is only as good as my weakest link. So if you notice, my answer mimics the number of places after the decimal. So my answer, therefore, has no places after the decimal as well. Because we don't know. I mean, maybe this is 2.1, 2.2, but my instrument didn't let me read there. I couldn't figure it out. Okay? So my answer is 3 centimeters. Remember, a centimeter plus a centimeter is just a centimeter. Okay? All right, let's look at another example. How about if I want to add these two numbers? 1.00 meters and 3.0 meters. So again, I look at these two and I say, which one did I use a better piece of equipment? Which meter stick was better? Clearly I used different meter sticks. This one I used a meter stick that went to the hundredths place, and this one only to the tenths. So clearly this one's my weakest measurement, right? It's the one with the least amount of places, one place after the decimal, right? The tenths place. This one goes to the hundredths. Well, remember, what's the rule? You're only as good as your weakest link. Okay, so my answer ends up being 4.0 only to the tenths place to mimic my weakest link. So you want to match the number of places behind the number with the least amount. Okay? Don't forget your unit. A meter plus a meter is just a meter. And lastly, here's our last example. I have 5.0 liters, goes to the tenths place. 1.000 liters, tenths, hundredths, thousandths place. Which measurement is better? Well, clearly this one is. Wow, look how many places I can read to. This one I can only read to the tenths place. So with that being said, what would my answer be? Take a second right now and try to see if you can guess. Hopefully you said 4.0. We're only as good as our weakest measurement, right? So you only want to go to the tenths place here because this one goes to the tenths place. So in summary, you always want to make sure that your answer, when you add and subtract, mimics the number of places after the decimal as your weakest measurement, as your measurement with the least amount of places. Okay? If you remember back in this example, 1, 2, 3 places after the decimal, that's a lot of places compared to 1. So I don't put 3 places behind here. I just put 1. All right, well, that's the end of your video.